In this video, we're going to talk about how to solve problems involving exponential growth and decay. So exponential equations have the form y equals a times b to the x, where a and b are constants and a represents the initial value, b will represent the rate of change. We can use these equations to model exponential growth and decay problems, where a will be the initial value and b is the rate of change. So that's going to tell us whether we have growth or decay. We'll have growth when b is bigger than 1 and decay when b is between 0 and 1. If we look at the graph of these equations, we can see whether we have growth or decay. Notice here if we have f of x equals 3 to the x, so that's a b that's bigger than 1, you can see the function is increasing as we go to the right. This is exponential growth. If we have f of x equals 1/3 to the x, that's a b value that's between 0 and 1, so this represents decay. You can see the function is getting smaller and smaller as we go to the right. So now let's look at this problem. So does this function represent exponential growth or decay? Well, to find growth or decay, remember, we're going to look at the value of b. Here we can see that b is equal to 1.05. So that means that this is going to be exponential growth because b is bigger than 1. The initial value of this function is given to us by a, so that's going to be 2,000. The rate of growth or decay, well, in this case, we have growth, and that's going to be equal to 1.05, which is our value of b. Now you can pause the video and try doing this example on your own. Here we have a function that represents decay because our b is equal to 0.65. The initial value of this function is going to be 5575. That's our value of a. This represents decay, and our b value is equal to 0.65. That's the rate of decay. So now let's try this problem. It says, suppose a scientist is studying a bacterial colony. The colony starts off with 4 bacteria, and the number of bacteria doubles every hour. How many bacteria are there after 5 hours? So remember, we're going to use y equals a times b to the x to model this problem. So we have y equals the initial value. Well, we start off with 4 bacteria. So we have 4 times the rate of change. It tells us it doubles every hour, so that's going to be 2. So we want to know how many bacteria are there after 5 hours. That means that 5 is going to be the value of our exponent. So if you want to know how to type these in your calculator, it's a good idea to go to Desmos. Okay, if you go to desmos.com, you can pull up all these different calculators. And using the scientific calculator can be really helpful when you're working on these exponential equations. So I'm just going to type this in as 4 parentheses, 2, and then I use this little exponent right here, this a to the b to get the exponent. Then I type 5. To click out of the exponent to close the parentheses, and when I hit enter, it tells me that the value is 128. So in this problem, that's going to be y equals 128 bacteria. So now you can go ahead and pause the video and try doing this example on your own. So here you start off with 12 M&Ms, so you have 12, and then your friend takes half of them every hour. So that's going to be our rate of change, which is 1/2. We want to know how many M&Ms you have after 2 hours. So this is going to be 12 times 1/2 to the 2. So now I'm going to go to my Desmos calculator and I'm going to type this in 12 parentheses, and then I can use this fraction, and I just type in my fraction 1/2. And then I'm going to close the parentheses and use my exponent button to do my exponent of 2. So you can see that that tells me that I have 3 M&Ms after 2 hours. So I also want So now I want you to realize that sometimes in exponential growth and decay problems, you'll be given the growth and decay rate as a percentage. Okay, so you see in these previous problems, we were given the growth and decay rate as a number. Here we had 2, right? Because it doubles every hour. Here we had 1/2 because we just had half every hour. But sometimes they'll actually give you the growth or decay rate as a percentage. And when we have a percentage, we have to modify our equation. Instead of b representing the rate of change, we're going to have 1 plus or minus r. So let's look at this formula a little bit more closely. A will still be the initial value, but then we'll have 1 plus or minus r representing our rate of change. If it's a 1 plus r, that's going to represent exponential growth. If it's a 1 minus r, that's going to represent exponential decay. So another thing I want you to realize is that most problems will represent a change over time, which is why we changed this x we had in the exponent to a t, because usually the variable will be time. Another thing to remember is that the rate of change r is going to be given to you as a percentage. So you'll have to convert it to a decimal before you plug it into this equation. So if it tells you, for example, the rate of change is 12%, you have to move the decimal 2 places to the left and change that to 0.12 before plugging into this equation. So, how do you determine whether you have exponential growth or decay? So, when you're working on these problems, you'll have to read the problem carefully and figure out whether I need 1 plus r or 1 minus r. And a good idea is to look for some key words that'll tell you whether you have growth or decay. If you see increases, grows, appreciates, or increases in value, that's going to tell you growth. So, you'll need 1 plus r. If you see decreases, decays, depreciates, or loses value, you're going to have to use 1 minus r because you'll have exponential decay. So let's look at some problems. Here it says the population of a small town grows at a rate of 2% annually. The population in 2014 was 5981 people. What is the population in 2024? So remember, the formula that we're working with is y equals a times 1, and then we have to figure out plus or minus. Well, here it tells us that the town is growing. So that's going to be a 1 plus r, and then we're going to raise it to the t power. Now we need to figure out what it is we need to plug into this equation. Well, A is going to be the initial value. Well, it tells us in 2014, we started off with 5981 people. So that's going to be our value of A. And then we have our value of R. So here it tells us that a rate of 2%. Okay, but remember, we can't plug it in as a percent in our problem. We need to convert it to a decimal. Remember, for a whole number, the decimal is at the end. So we move it to the left 2 places. And if we have an extra place, we add in a 0. So this is actually going to be 0.02. So now let's go ahead and plug into our equation. We have y equals 5981 times 1 plus 0.02 to the t. So that's y equals 5981 times 1.02 to the t. Well, now what are we trying to solve for? Well, we're trying to figure out how many people in 2024. Well, the thing to think about here is how much time has passed. Where was our starting point? Our starting point was in 2014, right? Our ending point was in 2024. So, how many years between 2014 and 2024? Well, that's just the difference, right? We do 2024 minus 2014, which is equal to 10 years. Okay, so that 10 is going to be our value of t. So we have y equals 5981 times 1.02 to the 10th power. So I'm going to now go to my calculator and I'm going to plug this in. So I have 5981 parentheses 1.02, and then I'm going to close that and do my exponent, the a to the b, and we do 10th power. When you hit enter, it tells us that we have this value right here. But whenever you're writing answers to these problems, I want you to think about what we're talking about. We're talking about a population, right? So we're talking about people. It wouldn't make sense to talk about a fraction or a decimal of a person, so we're actually going to round this value. Okay, you see it's 7290.8. Since that 8 is bigger than 5, I'm going to round up. So I'm going to say 7291 people. Okay, because whenever we're talking about people or animals or any objects like that, we want to make sure and round to the nearest whole number. So here's another example. It says the value of Sam's car depreciates at a rate of 8% per year. The initial value of the car was $22,000. What will his car be worth after 12 years? Okay, first we need to think about what form of the formula we're going to use. So we have A times 1, and it tells us depreciates, right? So that's going to be exponential decay. So it's going to be 1 minus r to the t power. Now let's figure out our variables. Well, we have A equals the starting value. The initial value of the car was $22,000, so that's $22,000 for A. R is actually the rate, so that's 8%, which we need to convert to a decimal. So we're going to move it 2 places to the left, which gives us 0.08. And then the value of T, well, it's asking us after 12 years, so we know T is 12. So let's plug that all in. We have Y equals 22,000 times 1 minus 0.08 to the 12th power. So that's y equals 22,000 times 1 minus 0.08 is going to be 0.92. That's 0.92 to the 12th. So let's go ahead now and plug that into our calculator. So we have 22,000 times 0.92. And then we do exponent and then 12. And we hit enter, and that tells us this. So here we're talking about money, right? So we're talking about money. It does make sense to have dollars and cents in our final answer. So I'm going to round to the hundredths place. So I'm going to say $8,088.66, right? So we can round money with rounding to the hundredths place. Okay, so that's going to be the value of his car after 12 years. So now you can go ahead and pause the video and try doing this example on your own. So here it says the first year of a charity walk had 500 people in attendance. So that's telling me the value of A is 500. It says the attendance increases, so I know I'm going to use the exponential growth function, A times 1 plus R to the T. So we have 500, and then the value of R is going to be 5%. So we're going to move the decimal 2 places to the left, so that's 0.05. And then we have the value of T. It says how many people in the 10th year, so T is 10. So we have Y equals 500 times 1 plus 0.05 to the 10th power. So Y equals 500 times 1.05 to the 10th power. And let's go ahead now and use our calculator to help solve this problem. So we have 500 parentheses 1.05 1.05 close parentheses, and then exponent to the 10th power. And we hit enter, and it gives us this value. So remember, we're once again talking about people, so we don't want to round to any decimals or fractions. So we're going to say that Y equals 814 people, right? We round to the nearest whole number, and we round down because that value 4 is less than 5. So remember that for exponential growth and decay, you can use the formula y equals a times 1 plus or minus r to the t, where a represents the initial value of the function, r represents the rate of change, and t represents time.